Bless you. Okay, in this video, we are going to talk about word problems where you may need to use logs or log properties, things like that, to get your answer. So let's look at our friend Mark here. He started a new blog to write about his travels. In the initial week, he had 800 readers, and then each week he got 25% more. So that's 25% increase, 1.25. We want to find when he's going to get, so it's time, right, in weeks. So T is in weeks. We want to find the time it's going to take for him to reach 10,000 people. This would be how we would set up this problem. So it's pretty straightforward, but it's going to use a logarithm, right, which is slightly different than what we've done in the past. So the first thing we could do is just divide by the 800, I suppose. Divide by 800 to isolate the exponent, isolate the exponential part of it. 100 over 8, I don't know. Maybe we'll just make that 25 over 2. Is that okay? 25 over 2 equals 1.25 to the t. Now you can do log base 1.25, or you could ln both sides. I get kind of in the habit of like just using ln because there's a button for it on the calculator and it's on all calculators. And I don't really love to do the change of base formulas, so what I'm going to do is I'm going to have ln of 1.25 to the t, but I'm going to bring the t down. This is the magic that just happened. This t was brought down because there was an ln here. Okay, I just tried to save myself a step. I can now use my calculator to just get decimals for these. So basically I'm going to use my calculator like on the side here, so it's not going to be on the video. So I'm just going to type in ln, and I'm going to use the fraction 25 over 2, and I'll hit enter. And then I'm going to use ln, and I'll put 1.25, and I'll hit enter. You should be very careful about carrying over decimals. So what I do is, because we're trying to round to 3 decimals, I carry like 5 decimal places. Now, smarter teachers would tell you to like store those variables. I'm not one of those teachers, I guess. So 2.5257.3. Okay, that's what I got for that. And then the t is going to be 0.22314 t. We'll divide those. So if we take 2.52573 and divide it by 0.22314, we'll get 11.319. So I'm going to go over here now. Sorry about this. But what they really want to know is what week will he actually get the amount of subscribers he wants, right? So we could round that to this, or we could say 12 weeks. That's maybe what I would say. I was like, this is the number, so 12 weeks. I kind of like having both, personally. Okay. So the next one is basically just talking about a continuous growth model. So just remember that that is A equals P ERT, but I am going to skip it because we're going to do a project on this. We're going to do so many of these. You're going to do awesome. Okay. In this case, you're finding the growth rate, which is this guy. But let's go to one more. This is the half-life, I think. And half-life tends to be like sometimes confusing people a little bit. So the half-life is 5 hours. So they were given 500. I'll use green for start, like green means go type of thing. And now we're going to take half of that, right? We want to know at some point they're going to have 100 milligrams in the end. So we also have that, right? Let's think about this half-life of 5 hours. So I think what we would like to do is find the number of half-lives and then multiply it by 5. I don't know if this is maybe the best way, but I don't mind it. So the half-life is 5 hours, so why don't we find the number of half-lives and then just multiply that by 5. Seems like a pretty okay way to do it, right? So 5 half-lives, 5 times the number of half-lives is the number of hours, right? And I'm using H for half-life, not for hours. I know it's confusing. So I guess what we'll have is we'll have 1/5 equals 1/2 to the H. This will give us the number of half-lives. We can do ln on both sides if you want, or we can do log base a half. Let's try it the other way this time. Log base a half of 1/5 equals H. We can then realize that that's going to be ln of a fifth over ln of a half by the change of base formula. So we're doing this by a different method this time. I'm going to type that into my calculator. ln of a fifth is 0.2, so ln of 0.2, and ln of a half is 0.5, so I'll put that. And for me, I got a decimal of 2.322. So my half-life is 2.322. And I now know that that's 2 1/3 half-lives. I have to multiply that by 5. So the number of hours is going to be 2.322 times 5. I don't know why I use an X for that. I haven't done that in like since I was a child, basically. 2.322 times 5. I guess I won't round it. We'll see what happens. Maybe if you type that in, you'll get the same as me. 11.610. 11.61 hours. Okay. I could put a 0 there if you want to be sure you rounded to 3, I guess, but it's kind of whatever. Okay. Oh, I'm so sorry. So they said at noon, right? So this is good, but they actually want more to this, right? They said they were giving it at noon. So now it's 11, so it's 11 something p.m., correct? How do we figure out that? I guess we would just do 0.60 is like 0.610 times 60, right? 60 minutes. Okay. So 0.610 times 60 gives us 36 minutes, 36.6. So I'm going to say 37 is when we actually cross the threshold and we're actually able to take, let's say it's Tylenol, right? We're actually able to take more Tylenol, right? Once it actually gets past that time. Yes? Oh, interesting. Okay, let's take a look at that. Yeah, that's good. I'll try to look into it. I'm timesing by 5 because each half-life was 5 hours. So I found the number of half-lives. So this is the number of times, I guess, or the number of half-lives, if that makes sense. And then I multiplied that by 5. There might be a more efficient way to do it, to be honest. But I don't know. To me, it made sense, you know? So I found how many times it happened, and then I multiplied it by 5 because that's how long it takes, basically. Make sense? No? Okay. I will try to look into that. Let me hold on to this for now, just because I'm still mid-video here. Okay, we'll pause for just a moment here. Okay, so again, what we're trying to do is the formula for half-life, I think, was the time over the half-life. Time over the half-life. I kind of like took that out of the equation and I basically just multiplied the half-life times 5. So it took 2.32 cycles, and each cycle was 5 hours. So that's why it took this many hours. Then I wanted to figure out when we would be okay. We would be okay at 1136.6, but we're going to basically say 1137. We're going to go up so that we don't, get toxicity or whatever from this medicine. Take too much Tylenol, 0.4 of a minute too early. You know what I'm saying? It kind of seems silly, but we're going to go ahead and make sure we wait till that whole minute passes, and then 11:37 p.m. is our good time. All right, well, I hope that helps. We're going to, in our class, do a project on this where you'll get to work with people, and hopefully it'll become more clear as time goes on. We will see you in the next video. Peace.